So here we are at the drill press. I set my RPM to around 1,000, about what we had over there. I want to control my variables, and I'm going to use the same tool, obviously, the same drill, and the same cutting fluid, just to keep everything nice and even. And now with the same reamer that I used over on the mill and the same RPM, let's ream the A-holes. Yeah, I did just say that. The 4 holes are complete. We can now pull the part from the vise, we're done the machining, and head over to the surface plate to measure the position of these holes. Okay, so I have my block and I have my 4 1/4-inch dowel pins lightly press fitted in. Now before pressing them, I applied a small amount of 3-in-1 general purpose oil. You do not want to assemble dowel pins dry, especially not in aluminum. They can gall quite easily. So they're set up here. And I'm going to measure. Now I've measured with my caliper for what that's worth, and I can see that they are pretty close to being identical, but that they aren't quite identical. But just to make certain that we get as good a measurement as possible, well, I've broken out some Joe blocks. So let's put this down and zoom in on the part so we can take a look at this final measurement. Okay, so here we have 3 Joe block stacks and my 4 dowel pins. Now it's the distance A and the distance B that I want to compare here. Now I've already done the measurement, so I have my stacks already made. Here in the center I have 690 thousandths stack, and that's my base stack for my measurement. And at the top here I have a stack of 308 thousandths of an inch, because that is what fits just snug between the pins A. And I can see that that is just snug enough to hold them in place. So 308 thousandths of an inch here. So let's retract that and move over to the B side of the equation. And here I have a stack of 309 thousandths of an inch and 3/10. So I'll check that out here. And there we have also just snug as it was with the other one. So in this case we have 999 and 3/10. In the first case we had 998 and no tenths. So the difference between the two is 1.3 thousandths of an inch. 1.3 thousandths of an inch difference between the first pair of holes and the second pair of holes. And that is surprising. But really, it's not surprising to me. It's something that I've known for quite some time. Finishing on the drill press when the holes are properly positioned, as long as you have an accurately set up drill press, is an accurate way of working. So why go through all this demonstration to show you something that I could have just told you at the start? Well, it's nice to see the operations being performed, but it's also important to see that it's real and it's true. If you have to move your z-axis only to accommodate a reamer, well, it's probably a lot better to just move over to the drill press. And one way of avoiding moving the z-axis on those mills, well, is to exploit the mill to its fullest and your other tools, i.e. your good quality drill press, to its fullest. And by marrying the two, well, avoid a lot of headaches. Well, that indicates to us that if we plan a little bit and try to use the longest tool method, and if that doesn't work, we go to the tandem machining method, which is using a drill press in tandem with the mill, well, we can get away with not moving the head very often, and that is what I like to do. But if you do have to move the head and you want to maintain the alignment, well, there are three basic methods. There are many, okay, but there's three basic ones that we'll look at. There is the hard zero method. There is the collet indicator method, where we're going to install an indicator into a collet or into the spindle of the machine. And there's the laser method, which is something I've never done, but hey, we'll set something up and we'll test it and see what that's like as far as precision goes. So let's head over to the mill and take a look at those three methods. Okay, so here's my laser. It's not a laser pointer, it's a little laser level, and it's fixed to the side of the machine here just with magnets. It's not a permanent installation. I've never used this technique, but if this test proves to me that this is an accurate way of working, well, I'm definitely going to make this a permanent installation, more than likely directly onto the side of the casting of the head over here. But I do have one problem, however, and that is that this machine is very perpendicular as far as the column goes to the table. But my machine itself is probably not perfectly level. And that is a problem if I'm going to be projecting a line over onto the far wall. So what am I going to do about that? Well, I'm going to make a little setup to make sure that the line that I'm comparing to over there is at the same exact angle as the column is on this mill. I'm going to want to ensure that the angle over there is the same as the angle over here. And what I'm going to do for that is I'm going to spot 2 points on the wall over there with the laser, mark them, and then draw a line through them. And I'm going to get the first mark at the low point here, and to transfer I'm going to use my quill. So what I'm going to do is I have a dowel pin, a 1/2 inch dowel pin mounted in this chuck. I'm going to lower the dowel pin so that it comes into this V-block and then tighten it into the V-block. And that's going to be my zero position. Once I'm tightened into the V-block and the V-block is tightened down onto the table, I'm going to turn on my laser, go over to the wall and make a mark where the laser strikes the wall. Then I'm going to raise the head by probably about 5 inches. I'm going to lower my quill to reinsert this dowel pin in the V-block, or in other words return to my same exact position, go over to the wall and mark the second point, which should be 4 or 5 inches above the previous one. Once I have that second mark, well, I can scribe or draw a line on the wall through those 2 points, and that'll be the reflection of the angle of the column on my mill. So let's do that. So my first point is marked on the wall. Now I'm going to loosen off the pin in the V-block. I'm not going to move the V-block. I'm not going to move the table in any of its axes. I'm just going to loosen the pin in the V-block. Then I'm going to raise the head 4 or 5 inches. Then I'm going to bring the quill down, re-snug the dell pin into the V-block that hasn't moved. It's in its original position. And go and mark my second point. Good, everything here is tightened down. I should be in the same position about 5 inches higher up. So let's go make that second mark. And now we can draw our line. Now, I've been filming this video over a period of a couple of weeks, and it doesn't usually take me that long to do the filming. The editing takes me a good long while, but the filming doesn't usually. But this sort of patchwork, and it's been quite a while, so I have lost all sense of continuity here. I started off with a dark blue sweatshirt, then I went to a red t-shirt. Now I can't find my red t-shirt anymore, so now I'm with a powder blue polo. For the rest of the video, I'm just not going to be careful with continuity. So what can you do? I'm letting my hair down. So let's get back to our problem here, which isn't a problem really. Our laser is still on. I'm still lined up with my line. I've lowered my head and I'm still aligned, which is a good sign. My pin is still solidly fixed in the V-block, but now I want to perform a blind test. Now I've calculated here the distance between the column, the center of the column, and the center of my quill, okay, is about 10 inches, and I have something around 13 and a few inches feet between the column, or 14 and something anyhow. I don't remember the calculations, I've made the measurements, but it works out to about 18 to 1. And that means that a 1 thou error in positioning of this quill, the center of the axis of the quill, and the wall over there is 20 to 1 or 18 to 1 about. So 18 thousandths will show up on the wall over there for each thousandths out that I have here, which is not bad. Okay, that's pretty good. Obviously if my wall was further away, I'd get a better ratio and more distance, but seeing as I'm getting older, I'm losing eyesight, well, I didn't feel like bringing out the binoculars to be able to see now. I know some people suggest using mirrors, but that for me in this test just introduces a whole pile of more variables that I would have to control. So to keep things simple, I'm just going straight from laser to wall, okay, no angular refractions or stuff like that. That being said, what am I going to do? I'm going to perform a blind test. Well, not blind in that I can't see the dot on the wall, but blind is that I'm not going to try and control what's going to happen. I'm going to loosen the pin in the drill chuck. I'm going to leave it in the V-block. Then I'm going to pull the head up, and I'm going to align the laser on the wall visually from where I'm standing here. I'm then going to lock the head in that position, and then I'm going to get out my old trusty last word starred dial indicator. I've had this one for almost, well, probably 40 years. So I'm going to get it out, and I'm going to indicate my pin from where I think I'm aligned, and that'll give us an idea of how close we managed to get the alignment just using that line from this distance. So let's do that. About 5/1000ths of an inch. Now, some would say 5/1000ths of an inch isn't that good, but that's swiping side per side with the indicator. The center axis here is actually aligned within half of that distance, so 2.5 thou. And I didn't pay particular attention to the alignment over there. I went visually. Me, Mark, blind as a bat LeCuyER, didn't use any visual assistance, but obviously had I used binoculars, and take a look at these are Jumelles Chevalier, okay, Chevalier binoculars. They've got to be 100 years old if they're a day old, and they used to belong to my grandfather, and they still work just great. So had I used binoculars, and had I increased the distance, well, I would have easily gotten it within a couple of thou, or probably consistently close to 1/1000th of an inch. Because if I had 25 feet distance that I just couldn't see, but with this I could, if I had 25 feet distance, I'd be getting a ratio of about 30:1, and it'd be pretty easy to see. 1 thou here, 30 thou there, we're starting to talk about something that's easy to catch on to. So this is a viable way of keeping the head aligned. Now if you're working to very tight tolerances, now this is no good. But within a thou or two, in other words, most jobs for home shops, well, this works just great. Now, the other techniques that I want to show you are the hard zero techniques, and the swiping technique that I really don't like. I'll just explain. But let's take a look at the hard zero, or the machine zero technique, since we're still going to be using this V-block and this pin and this indicator. So let's take a look at that. For this next method of maintaining the head alignment after a vertical move, we're going to be needing two stops. One stop on my x-axis and one stop on my y-axis. Now, most of these machines have this T-groove on the front here that can be used for inserting stops. And I have a stop here and its counterpart here. So this will stop the table in a specific location in my x-axis. But many of these machines don't have stops in their y-axis, so you're going to want to add one on. And here's what I suggest as a quick way of setting up a stop on your y-axis for these machines. Come on in a little closer, it's down here. So here is that stop. Now all it is a large or an oversized washer with some support washers to give it some stiffness. And I've drilled and tapped, in this case, a 5/16 18 thread, and I've bolted it to the face, and this provides a stop. But to not impede my movement, because I don't want to use this stop all the time, actually I'm going to use it quite rarely, I've made it so that there's a flat there, and when in this position, the flat upwards, well, my y-axis has its complete movement. But if I pivot the washer into position, snug it down, I have a stop that will position my table in the y-axis accurately time after time. So my stop is touching down here. On my y-axis we're positioned. Now on my x-axis I'm going to bring the table over and lean my stop up onto its counterpart, and I'll have my table positioned in X and Y. So there, I'm leaned up here, and here I'm at my machine 0 in X and Y. So hard 0, machine 0, permanent 0, whatever you want to call it. It's not really important, but what it is a place on the table that you can go back to if ever you get lost. In other words, if ever you move your head and you don't remember, or you can't bring it back to where it was, well, you're going to return to your machine 0. And for that, you're going to need to set up a pin, a reference pin, okay? And that pin is going to be ground 0 when your stops are in contact in X and Y. So I return to X, I return to Y, and then I set up my reference pin or my 0 pin. Now, you can do this many ways. This is not something that I do or that I would use often, so it's not something I leave on the machine. So when I do have to do it, I use a nice vblock and a large dowel pin, and using my positioning hammer, I very delicately move the pin around until I get a 0, 0 reading, and then clamp it down to the table. It's important when you position the pin under the spindle that you don't use the table to move it. I mean, you have to have this at 0 when you're leaning up on your stops. That's the whole reason for doing it. So you really have to lightly tap your V-block around to get it positioned right in line or right under the spindle of your machine. So let's take a look here. There, we can see that the pin is really well within 1/1000th of an inch in line with the spindle rotation axis. Now that my machine 0 is set up, it's there, it's positioned, well, I can remove my dial indicator and install a tool and go machine something. Now we're not actually going to work here because, hey, I'm lazy, but I'm going to install a tool just the same, just so we can see what the basic principle here is of how to use that machine 0. So let's get that indicator out. So let's say that that is the 0 for my part. Now, my hard 0 or my solid 0 or my machine 0 over here, But my real zero for my part is here, and it's not on any stops. So I came to this zero going this way and that way. So I'm going to set my dials to 0, and I'm going to mark my tables with the chalk. So chalk line, chalk line. Now, as we've seen in many other videos that I've produced, we can come back to that machine, to this reference zero on my part, my working zero, because all I have to do is remember what direction I was moving in when I set the zero. So I was going that way and I was going this way. I can return to it because all I have to do is come back to my chalk line, pass it, and come back in the direction that I was working in. So I'm at 0 here, 0, 0, but I have a machine zero. So let's say somewhere down the road I decide that I need to move my head. So I move it up and I lose my reference. What do I do? Well, I have my stop and my stop. I return to those stops. I indicate my pin without moving the pin or the block of the pin at all. I'm going to indicate the pin by pivoting the head around the column. That will bring me back to my proper alignment. Once I'm over the pin, I lock the head down and I return to my marked zeros, and I'll be precisely where I was at the start before I moved the head in X and Y. That hard zero method is pretty complex, but it is a good way to ensure that you don't get lost on a complex project, because if things do get out of hand, well, you can always go back to something that physically won't change those stops. Now, if you want to do something quick and dirty, we'll look at this last technique that again is going to use the vblock, but in a much less pre-planned manner. Okay, it's really rough and ready, but it's the chanciest of all the methods, and it's probably the one that gives the least dependable results. This last technique really is rough and ready, and we're going to be touching off on a reference point, but a reference point that we set up specifically for each movement of the head. So let's say that I'm on 0 here and I want to move the head of the machine, but I'm not going to be moving anything else. I want to stay there. Well, obviously when I move the head, I'm going to lose my reference. So before I loosen the head off, I'm going to position this long pin. It's an accurate but quite long pin in a V-block so that it's very perpendicular to the table, and I'm going to set up some kind of touch-off mechanism. Now we could set up a dial indicator here and make ourselves sick, but really it's not that important. This is the rough and ready method, and I bet you never thought you'd be using a pair of vice grips for accurate positioning on a mill, but hey, if you live long enough, you see everything. So here's a dowel pin mounted on a pair of vice grips, and really I just have to position the X. So I want to put this so that this touches off on my pin somewhere as next to the 0 as possible in the X-axis. So it's going to be somewhere over here. So I'm going to position myself here, so that's a little tight. Just come up, just barely. Now if I wanted to be touchy here, I could use, there, I could use a little piece of shim stock or a thickness gauge that I could just barely lean up onto the machine. So now, as you can see, I have a reference. I'm just barely touching here on that pin. Now I can loosen the head off, move this as I feel fit to move it, but before I tighten the head back down, I have to come back to this same position. Okay, so obviously I don't want to move anything here. I come back to this same just barely touching position and I lock everything down. I should be pretty close to where I was before I performed the vertical movement on the head. It's important, however, to remember that this last technique works because really the head doesn't move in X and Y, it pivots around the column. So as long as my pin is next to my 0, roughly in my X axis, well, once I position the X by just barely touching off, my Y will fall into place naturally, as long as I don't move anything. Now, obviously this is a one-shot setup. I'm going to set up my pin for each movement, but it is pretty quick to set up. So let's recap here. Vertical machines, vertical milling machines that have round columns have a problem, don't we all? But anyways, their problem is that when you move the head, you lose your references. So how do we deal with that? We've seen many ways in these last two parts of this video. Now, the first and obvious one is to use the longest tool method. If that's not possible because there's too much a difference between the longest tool and the shortest tool, well, we can also revert to a combo, and that is perform part of the machining operations on the mill and complete operations that use very long tools such as reaming on the drill press. And we've proven with our little experiment that that is a very accurate way of working, at least accurate enough for the vast majority of home shop operations. We also did some testing with a laser pointer, or in my case a laser level, that we shined onto or shone onto a wall, in my case about 15 feet away. And we showed that, hey, that was pretty accurate. So I put that option in the third place to get within a few thousandths of an inch. If you really are careful with what you're doing, that laser method seems to work quite well. The most complex method to use, but the one that's really bulletproof, I'd place in fourth position, and that was the hard stops. To use a hard stop in Y and a hard stop in X, and to use a hard 0 on the table as somewhere we can go back to if we get lost when we move the head on the machine, and reset up our 0 without losing where we were. And finally, for quick jobs, when precision isn't all that important, well, the rough and ready touch-off method that we saw at the very end there, which is probably the quickest method to use, but I would say the least accurate method. So there's some options. And there's other things we can say as well, like using a swivel-based vise that gives you some height. Now if you have to change tools, sometimes you just need that little bit of space to be able to wiggle the tool into. Well, if you have a swivel-based vise, your part is going to be quite high off the base of the table, or off of the table, and if you just move sideways, it gives you a lot of room once you've cleared your part to do tool changes. And if you mark your table and set up your zeros, as we've seen many times, well, you can always come back. So there are a lot of options for these machines. So I hope that this answers a lot of the questions that I've been receiving about those round column mills. But one thing that it doesn't answer is it worth buying this type of machinery? And the answer is yes. It depends on your needs. Now, some people have sounded in and saying that, oh, that's a lot of work with those machines and they're not productive machines, and I agree wholeheartedly. But I'm talking about home shops here, and I'm talking about beginner machines. And for that, this really cheap, as in inexpensive type of machine is often a good way to start anyways, and a good way to finish. Now, I've worked on some of the best machines around, and I was lucky in my life working at the National Research Council to have access to those machines. Real beautiful machinery. But at home, I do what? I fix my lawnmower, I make parts for my bicycle, I do repairs for things around the house, make parts for my cars or whatnot. But this is not rocket science. I'm at home making parts for everyday use. And these parts need to be accurate, yes, but we're not talking about 10,000ths of an inch here. And for that, if you don't want to go broke, well, these machines are just great. However, if you want to go into business and you want to be productive and you want to produce a lot of parts as quickly as possible, obviously a traditional knee mill or something like it is probably the way to go. But for me, at this point in my life and the type of work that I'm doing now, well, these round column mills are just grand. So, as I normally say, have fun, be safe, it's important, and happy machining.